For this question, I'm given a function f of xy and E, which is a closed disk of radius 2 centered at 0, 0. And I want to find the maximum and minimum values of f on that region E, and then say where each of those values occurred. So basically find the points that are the extrema and then the function value at those points. So the first thing I want to do is check the gradient of f for when it equals 0. So I need to find its two partial derivatives, f sub x, f sub y, and set them equal to 0. Let's start by finding f sub x. It's going to be 6x minus 3x squared. And I'm going to factor out a 3x. Set it equal to 0, and I get x equals 0 and x equals positive 2. All right, now let's do the same for f sub y. F sub y equals negative 8y plus 4y to the third. So let's go ahead and factor out a 4y from that. Set it equal to 0, and this time I get three values for y. 0, positive square root of 2, and negative square root of 2. And now I just want to write out all the points where the gradient equals 0. So basically all combinations of x and y here. And at the end, I'm going to check all of the function values of these points. And then the points with the greatest value are where the maximum occurs, and the lowest value where the minimum occurs. So I'm going to get started over here on a list of points. So the first one is going to be 0, 0. Then I have 0, negative root 2, and 0, positive root 2. And then likewise for x equals 2. I get 2 root 2 and 2 negative root 2. At this point, it's good to talk about that we want to make sure that all of these points are actually in our circle E or on its boundary. So obviously the origin is fine. That's the center of E. These 2 points are good. This point lies on the boundary, so we're fine. But these 2 points are actually outside of the circle. They lie a little bit above and a little bit below, both to the right of the circle. So I don't need to worry about checking these points. So I've checked the inside of the circle. Now I want to make sure there aren't any more points on the boundary of the circle I need to be checking. So what we want to do is write a function for f of xy along the boundary in terms of one variable. I'm going to call it g of x. So I know that my boundary is going to be defined where x squared plus y squared equals 4. I'm going to solve that for y squared. I get 4 minus x squared. So I can go ahead and plug that into f for y squared, and then for y to the fourth, I'm just going to square that quantity. So 16 minus 8x squared plus y to the fourth. Let's go ahead and plug those into f of xy. I'm going to call my new function g of x. The original terms of x from f of xy just stay in there. And then I want to subtract 4y squared. So minus 16 plus 4x squared. And then I want to add y to the fourth. So plus 16 minus 8x squared plus x to the fourth. I just want to add all of these up. So I've got x to the fourth minus x cubed combined terms for x squared, I have 7x squared minus x squared. That gives me negative 1x squared. And then plus 16 and minus 16 cancel each other out. So I'm good. I have an equation for g of x, and now I just want to find its first derivative and see when that equals 0. So I just rewrote that, and let's go and find its derivative. It's going to be 4x cubed minus 3x squared minus 2x. So I want to set this equal to 0 and factor. So the first thing I'm going to do is go and pull out an x, since there's an extra factor of x in each term. So right away, I know one of my x values is going to be when x equals 0. And then I can use the quadratic formula to find the roots of the rest of it. You probably are going to want to do this in your calculator. It's going to be 3 plus and minus the square root of 41 over 8. And when I did that in my calculator earlier, I got 1.18 and negative 4.3. I'm sorry, negative 0.43. And then I just want to find the y values associated with that. So I'm going to plug all of those values for x into this equation for y squared and then take the square root. So for x equals 0, y squared equals 4, y equals plus or minus 2. And then for 1.18, y equals negative 1.68, or plus and minus, excuse me, plus and minus 1.68. And then for negative 0.43, y equals plus and minus 1.95. So I can use this information to add 6 new points to my chart over here that I need to check. So I have 0, 2, and 0, negative 2. Plus 1.18, comma 1.68. And 1.18, negative 1.68. Then I've got negative 0.43. And 1.95, and then negative 0.43. Comma negative 1.95. So I'm almost all set. I just need to check the boundary for g of x. So for f of xy, we checked inside the circle, but also the boundary. So for g of x, we checked the values of x between negative 2 and 2. Now we need to check when x equals negative 2 and when x equals 2. So I can use that y squared equals 4 minus x squared equation again to find out that when x equals 2 and when x equals negative 2, y equals 0. So those are 2 more points I need to add. One of them is already on here, so I'm just going to add negative 2, 0. In a sad chart by itself. So now I just want to find the function values of all of these. So I'm just going to plug the x and y components into f of xy. I did all of these earlier, most of them I did in my calculator, so you could do that as well. I'm just going to write down all the function values that I got, and then we'll take a look at them. So at 0, 0, f equals 0. For these 2 points, f equals negative 4. At 2, 0, f equals 4. And then for both of these points, f equals 0. And for both of these points, leading with 1.18, we get negative 0.789. And then for both of the points leading in negative 0.43, we get negative 0.132. And then for the point negative 20, we get 20. So our maximums are going to occur at the highest value or values if there are two with the same value of f, and then likewise the minimum will occur at the lowest point. So if I look through, I can see that the highest function value is attained at the point negative 20. So that's our maximum. And f there is equal to 20. And if I look for minimums, I can see I actually have two minimum points at 0 plus or minus the square root of 2. And that function value there is going to be negative 4. So f attains a maximum value at the point 20, and f attains minimum values at 0 square root of 2 and 0 negative square root of 2. And we are all set.